Okay, we're back. Pen is now working. It froze before and would not get off the highlighter, so I had to make a part 2 of the video here. Okay, so like I was saying before, I think that there would be some people that would be able to eliminate some of the choices right away because it's asking for a recursive formula. So if you look at choices 1, 2, 3, and 4, 2 of them are in a recursive format, and 2 of them are in an explicit format. I'm hoping that you could see that choices 2 and 4 are in this format. The explicit formula for a geometric, this is explicit. And it's asking for recursive. So we can get rid of choices 2 and 4 right away. Recursive formula is where you're always going to have the first term, and then you can see they're writing it as the next term is equal to half of the one before it, right? Or in this case, the next term is equal to twice the one before it. So we just have to figure out what the common ratio is in this question, and we could pick which choice it is. So common ratio, second, divided by first, and my common ratio is 1/2. If you put in your calculator 18 times a half enter times a half enter times a half enter, this guy works. So choice 1 is my recursive formula. But again, it's all about figuring out, what's the format. These 2 right here are, this one and this one are in a recursive format. And we can see that this guy and this one are definitely looking like the explicit. So great question to know there. All right, now they're going to use n+1. All right, so let's go back to our number line. So if I were to make a number line, here's n+1, and here's n-1. So this one is saying write the first 5 terms of the sequence that could be generated by. So you guys, again, you're supposed to notice that this is recursive with the n and the n+1. So where is n+1? n+1 is over here. So isn't that the next term? So the way we say this is the next term is equal to twice the one before it, because see how that's the one before it? They're giving me the first one is 4. So the rule basically is just a times 2 pattern. So the next term is equal to twice the one before it. So it's really just a times 2 pattern. And that would be my answer. All right, let's try a Regents question here. And again, I know there's going to be some of you out there that if we were in class together right now, you would be getting rid of choices for me immediately, which is fantastic. Okay, so let's see. The population for Jamesburg of the years 2010 to 2013, respectively, was reported as follows. Which sequence can be recursively modeled? So again, which 2 choices? I see 2 right away that we're eliminating because they're explicit. And remember, explicit formula for geometric would be where you have that exponent. Right? Can we see that this is the explicit, those 2 are the explicit formula for geometric, and they want recursive. So those 2 are out the window. Those are gone. So if we look at these, it's in the correct format. So we have to figure out which one's right. But look, they give you the first term, which they're supposed to. And then we can see that it's the next term, right? The next term is equal to the one before it times something or the one before it plus something. So we just have to figure out what kind of model this is. So let's go back up and let's test it out. So first I'll test out arithmetic, and then we'll test out geometric. So arithmetic, we're going to do second minus first. So these are pretty large numbers here. And we get a common difference of 937. Now this is what's super important. You go back up to the top and in your calculator, 250,000 plus 937, enter, plus 937, enter, plus 937, enter, and see if that works. But it doesn't work. So this better be geometric. Common ratio, second, divided by first. So my common ratio comes out to be 1.00375. Remember, you got to be in float and use all these numbers. So how do we check this one? Go back up to the top, and let's do this number times the common ratio, enter, times the common ratio, enter, times the common ratio, enter. And we can see that this is indeed the one that works. Okay, so redo that question if you have to, and listen to all the little things that I said. Okay, now I want to go out of order because I like the flow better. So let's go to this one. I have a little note on my paper here that says on test. Okay, so this is an important one. I will give you one just like it. All right, while experimenting with her calculator, Candy creates this sequence. Write a recursive formula for Candy sequence. Okay, so we have to decide first, is this arithmetic or is it geometric? Well, I can see that I'm adding 5, but then I'm not adding 5 again. So that looks like this is not an arithmetic sequence. What if we try to figure out if it's a multiplying one? So I'm grabbing my calculator, and I'm going to do 9 divided by 5, and I get 1.8. So now I'm going to do 4 times 1.8, enter, times 1.8, enter. And I can see that doesn't work either. So this guy is not arithmetic, and it's not geometric. This is very similar to the one on day 1, the last question that we did when I gave you those little bubbles, and we had to figure out like what the sequence was. And I know in period 7, somebody figured it out. It was the one where it was a sub n equals n squared. Okay, so you have to figure out, what do you do? That's really sloppy. Let me write that again. That's bad. Actually, I'm just going to rewrite it myself down here. Okay, so the first term is 4, the second is 9, the third is 19, the fourth is 39, and the fifth is 79. Okay, so you have to figure out, what do you do to the position to get that number? And it could be a combination of adding, multiplying. So we have to figure out, what do we do to the, and remember, you're always looking at, oops, I messed up. Take away the positions. Sorry about that. We're not going to look at the positions because it's recursive. Okay, sorry about that. We are going to look at, because it's recursive, we're going to refer back. What do you do to the one before it to get the next number? So what do you do to this one? Come on. What do you do to the number 4 to get it to be a 9? And then whatever that rule is that you come up with, it has to work for this one too. What do you do to 9 to get 19? So I don't know if anybody is noticing it. The first term is 4. What do you do to the term before it to get the next term? Okay, so now I'll tell you. Pause it if you don't want to know. So to me, it looks like you're doing twice the one before it plus 1. So look, if you do twice 4, that's 8, plus 1 is 9. Let's do twice 9, you get 18, plus 1 is 19. So, you know, it's a little tough. You know, you just got to practice a little bit, and you will eventually get it. Okay, now they want the 8th term of the sequence. So explicit is kind of easier because we can use an explicit formula to always find the term. But recursive, you only have a rule, and you have to know the term before it in order to figure out the next. So let's just keep going here. So the first term is 4, the second is 9, third is 19, the fourth is 39, the fifth is 79. So we just have to keep using the rule to get that 8th term. So we're going to do twice the one before it, right? And that's just what this says here. Twice the one before it plus 1. So twice 79 plus 1 is 159. Twice 159 plus 1 is 319, and twice 319 plus 1 is 639. Okay, it's easy just to say it. Again, I'm going to say it up here again. So the next term is the one before it times 2. That's what that means. Okay. All right, next one I want to do is this one. Okay, they're giving me the recursive formula. And we can see they're giving me the recursive formula because they gave me the first term, and then there's, say it, the next term is twice the one before it plus 3. So we got a lot going on there. And they want me to state the first 3 terms. First, second, and third. So the first term is 4. So I'm just going to take the rule and apply it. So I'm going to go twice 4, because that's what it says to do, right? Twice the one before it. So twice 4 is 8, plus 3 is 11. Twice 11 is 22, plus 3 is 25. And there it is. It says, can the sequence be represented using an explicit geometric formula? Well, geometric is when we multiply. This is a combination of multiplying and adding, so the answer is no. Because geometric is a multiplying pattern. Okay, and now we're going to go back to this one. Like I said, I wanted to go a little out of order because I like the flow better. And we'll go to this guy here. Alrighty, so Little Region's question. The Rickards decided to set up an account for their daughter to pay for her college education. The day her daughter was born, they deposited $1,000 into an account, right? So we're going to start with 1,000. And it pays 1.8% compounded annually. Okay, so right away, when something is going to increase or decrease by a percentage, we know that it's exponential. And then because it's exponential, we know also that we can use that for a geometric sequence as well. Okay, so beginning with her first birthday, deposited an additional $750. All right, so if we keep an additional 7 into the account on each of her birthdays. Okay, so now I know also that this is like the question we just did. This is going to be a combination of multiplying and adding. So it says, which expression correctly represents the amount of money in the account n years after the daughter was born? So my eyes right away are going down to number 3. Right? I'm starting out with 1,000, and then the next term, right, the next term is going to be the one before it times, remember how to do this from the other day, from lesson 2, decimal to percent. If I have 1.8%, move it over 2 places, and we're going to have 0.018. This is an increase, so since it is an increase, we're going to add 1 to it. So 1 plus 0.018. So my common ratio is 1.018. So we can see that right here. And like this, you know, this makes sense. The next term is the one before it times that interest rate you're getting. And then I'm like, oh, by the way, I'm going to throw an extra $750 in on every single birthday as well. So this would be my nice recursive definition. Okay, and I'm going to go to number 9. All right, so I'm going to tell you right now, number 9 is hard. And remember, don't be stressed out if you don't get something. I want you to know that this is a tougher question. Whoops. I want you to know that it's tough. And if you don't get it, it's okay. But let's just do the best that we can. But it's definitely a tricky question. Okay, so the sequence, a sub 1 is equal to 6. Ooh. A sub 1 is equal to 6. And hopefully you guys can tell now that this is recursive. So the next term is equal to 3 times the one before it. I can tell that that's recursive. Now they're saying to me, this can also be written as. If you look at all 4 choices, you should be able to notice that there's an exponent there. So it looks like they're trying to write the explicit geometric formula. So let's try to write the explicit geometric formula using the recursive. So the first term is 6. The common ratio, isn't 3 the common ratio? That's the number we're multiplying by, to the n minus 1. Okay, so this is definitely the geometric explicit formula. So let's see. I think that we're going to get rid of choices 1 and 2 because those clearly are not the same as the one I produced. And now this is where, it gets interesting. And to me, this is definitely like a SAT type question. Okay, so what we notice is that we're subtracting exponents. So you guys are supposed to remember, when do we subtract exponents? And I'm just going to come off to the side here and kind of remind you. So if I had x to the 4th divided by x, wouldn't I subtract the exponents there? And I would get x to the 3rd. So again, this is tough. So just try to stay with me. And if you don't get it, it's okay. Let me move this up a little bit. So you're supposed to rewrite this as a sub n equals 6 times 3 to the n over 3 to the 1st. So what I just wrote is equivalent to this. And then hopefully, some of you guys would notice that 3 goes into 3 once, goes in twice. And so my answer is choice 3. Really tough question. So definitely more like SAT type thing where you really have to think. So you just do the best that you guys can. Okay, and let's do, I think I'm going to do 2 more. Sorry. My daughter's making lots of noises. All right, here we go. At least there's no cats crying or dogs barking today. All right, let's check this out. In 2010, the population of New York State was approximately 19,378,000 with an annual growth rate. Here it is again. We know that this is going to be some sort of multiplying pattern. Assuming the growth rate is maintained for a large number of years, which equation could be used to predict the population of New York State after 2010? So right away, let's take that decimal to percent again. So it's 1.5. So as a decimal, it's going to be 0.015. And then this is increasing, so we have to do 1 plus r to get that common ratio. So 1 plus 0.015. So my common ratio is this guy. That's your common ratio. So again, like immediately, like I'm seeing choice 4. Here's my value I'm starting with, and then each year all I'm doing is, and then just say it, the next term is the one before it times that amount. So choice 4 would definitely be my guy that worked. If you sat there and you substituted in and figured the other ones, those don't work. But recursive, there it is. I don't want to bore you with too much here. Okay, and then let's just do one more. We'll go to number 12. Oh no, we should do 11 too. All right, let's just do both of these. Okay, write an explicit formula. Okay, so now we're going back to day 1 and day 2. Write an explicit formula. This is what's going through your mind right now. Do I use this formula, the explicit for arithmetic, or do I use the explicit formula for geometric? So which one should we use? So is this a multiplying pattern, or is this an adding pattern? And hopefully you guys see right there that this is a multiplying pattern. So we're definitely going to use the explicit formula for geometric. And we'll just substitute in. A sub n equals the first term times the common ratio raised to the n minus 1. And that's it. And let's check out this guy. This was on a Regents. I didn't put the year down, but this is a great, great question. And I know that I have this one on my test as well. Okay, write an explicit formula. So just like number 11, I have to figure out, is this arithmetic or geometric? So write an explicit formula for the nth term of the recursively defined, right? So we can see this was recursive. Am I adding or am I multiplying? And again, hopefully you guys see that we're multiplying. We're multiplying by x. So explicit formula for geometric is this guy. And we're just going to sub in. So a sub n equals the first term, right? See the first term? You got to put that in parentheses because it's a binomial. So it's x plus 1. The common ratio, my common ratio, there it is, multiplying by x, raised to the n minus 1. So a little weird, a little different, just using more variables. But great question for you guys to know. All right, second part. For what values of x would a sub n be 0? So wouldn't I just plug in 0 for a sub n? So 0 equals x plus 1 times x to the n minus 1. So at this point, I'd be asking you guys, all right, what do you think we should do? And I think definitely that some of you would be like, oh, tee off, set each one equal to 0. Oh, there's a kitty. Hi, Liam. Hi. Okay, so we got x equals negative 1 right here. And now this one you have to do a little bit of thinking. So look, it's equal to 0. So what numbers can we raise? Well, yeah, I have to raise it to, so what numbers can be raised to a power? And no matter what it is, I'm always going to get 0. So I think, again, that some of you guys would get it. If you take 0 and you raise it to any power besides 0, you're going to get 0. So those would be my two answers. Alrighty, so that's all we had to do for this lesson. Now, homework for this one. So this is what I had for the homework. I have pages 21 and 22 for you guys to do. So in here, all this stuff. And then you're supposed to do this too. And I have the answers already there, so try not to look at the answers as you do it. So 21 and 22. I'm probably going to put a little delta up too, because I have to have a way of seeing that you're actually doing the work. Please remember to be taking all these notes, okay? It's super important that you guys are learning this. You have to try and do the best you can. All right, that's it for today.